Hi, this tutorial will walk you through the basics of chemical equations, what they require, how to write them, and how to balance them. In our last video, we discussed the fact that chemical equations describe chemical reactions which occur, and that they represent all the things that are going on with symbols and formulas. Okay, we also talked briefly about the fact that they must represent true facts. We have to actually know what the products and reactants are, that they have to have correct formulas, and that the law of conservation of mass has to be satisfied. That's the balancing part. We'll get to that in a second. So for now, let's start off with a few other things about chemical equations. What is this? Well, it's a sentence! It's a sentence. You already knew that. So, you'll note that it has a capital letter at the beginning, it has a period at the end, and it's all made up of words. That's a sentence. Typically, when we start to talk about a chemical reaction that has occurred, we describe it in a sentence. A sentence describes a chemical reaction. But there are a few steps between having a sentence that describes a chemical reaction. Calcium chloride reacts with ammonium carbonate to form calcium carbonate and ammonium chloride, and having a full-blown balanced chemical reaction. We're going to walk through these one at a time. So our first step will be to write a word equation. We've got our sentence here, and in a word equation, we're going to write in the names of the compounds that are reacting, and we're going to use symbols because we're moving out of the realm of sentence and into the word equation. When we start writing our word equation, we start by finding all of the reactants. And we're told that calcium chloride reacts with ammonium carbonate. Some other words that we might see there are combines with, decomposes into, any of those. And what that tells us is that a reaction is occurring, so we put a plus sign in there to indicate that these two reactants are coming together to form something else. Okay, so notice that we don't have any symbols, we don't have any formulas here, we don't have any chemical symbols, we don't have any formulas here. We have the names of the compounds, and we have a plus sign to indicate that they are reacting. Now, we have to finish by writing our products. I'll have to shrink this down a little bit to fit it in the space that we have, but before we do, I just want you to note, we've put an arrow here. This is the sign that a chemical reaction has occurred, and this arrow points in only one direction, meaning that this reaction only runs in one direction. We'll talk more about reversible reactions in a little bit. And we've written both of the products, calcium carbonate and ammonium chloride, with a plus sign between them to indicate that both of these things have been formed. As best we can do in the space available, we now have a word equation for the sentence describing this reaction. And a few things to note. The word equation still uses the names of the compounds, but those are the only words that appear there. Everything else that appears in a word equation is a symbol. The plus signs indicating that more than one thing is the product or that more than one thing has been formed, and the arrow indicating that a chemical reaction has taken place. That's not so hard. Okay, now let's move on to our second step. Once we've gone from a sentence to a word equation, we can now write what's called a formula equation. And a formula equation, as you might have guessed, replaces the names of the compounds or elements that are reacting with their correct formulas. So for each item in our word equation, we'll just write the formula. Calcium chloride becomes CaCl2. Ammonium carbonate becomes NH4 2 times CO3. Calcium carbonate becomes CaCO3, and ammonium chloride becomes NH4Cl. That's a formula equation. You will notice that it is not balanced. We haven't balanced this equation. It does not conform to the rules of the law of conservation of mass. But we very often use formula equations in everyday life or everyday speech. If you ever took a biology class, you probably learned the general formula equation for photosynthesis. Something along these lines. That's a formula equation. It's not balanced. It's not meant to be. It just gives us a slightly more precise picture, because we're using chemical formulas, of what our reactants and products are. The balancing is the next step. Okay, so now that we've learned to go from a sentence describing a reaction to a word equation to a formula equation, we now need to learn to write a balanced chemical equation. And balanced chemical equation is very often just described as a chemical equation, because the balanced is sort of understood. If you're writing a chemical equation, it darn well better be balanced. Before we learn how to balance, let's go back and revisit one point. That pesky old law of conservation of mass. The law of conservation of mass says that we can't make or destroy atoms inside an ordinary chemical reaction. We're not going to do this in the lab. It takes something like the interior of the sun or a giant atom-smashing super collider that's buried under the Alps to do that. It's not going to happen in a high school chem lab. And it's certainly not going to happen in your garage. So since we can't make or destroy atoms, we have to have the same number of atoms of every single element on each side of the equation. And we have to use coefficients in front of our formulas to equalize the number of atoms. If you change a subscript, you've changed a chemical formula, and you now no longer represent correct facts. And that was point one of writing a chemical equation. So with that, let's go on to how to balance. I have my own little method that I've found over the years works pretty darn well for balancing chemical equations. I start by rewriting the formula equation and leaving a blank space in front of each compound. I then draw a line directly down from the arrow indicating that a reaction has occurred to separate my reactants and my products. I'm then going to list every single thing that appears on the reactant side and the product side. Here I've broken it down into the individual elements that appear on the reactant and product side, and I'll go ahead and get a tally of how many atoms of each kind I have. A few notes. I realize that the elements do not appear in the same order in the equation on the reactant and product side. Of course, they've been mixed up. But I always list them in the same order for easier visual comparison. So I'll do my tally: 1 calcium, 2 chlorides, 2 nitrogens, 8 hydrogens, 1 carbon, and 3 oxygens to start with. And then I'll do my tally on the product side: 1 calcium, 1 chlorine, 1 nitrogen, 4 hydrogen, 1 carbon, and 3 oxygen. I can see right away that the equation is not balanced. I have different numbers of chlorine, nitrogen, and hydrogen, though carbon, oxygen, and calcium are already balanced. So, what I'll do next, is to start putting in coefficients, and a few hints and tips. As I put in coefficients, I cross out the number that I had and replace it with a new number. For instance, if I was trying to balance my nitrogen and hydrogen initially by putting a 2 there, I would go through and say, okay, I now have 2 nitrogen, I now have 8 hydrogen, and I now have 2 chlorine. What that does is it allows me to keep track of what I had and what I have now. It gives me basically a visual record of where I've been. And hey, look at that. We're now balanced. That one was pretty easy. But I'll tell you something that makes it even easier. Because this ammonium ion stays all together as an ammonium ion on the other side, instead of balancing my nitrogen and hydrogen separately, I can actually balance the ion as NH4. This does save a little bit of work. You have to be careful because sometimes you have situations where a polyatomic ion breaks up or decomposes across the equation. You'll notice that the carbonate ion also remains in one piece. So I can balance the carbonate ion as a single unit too. Just saves you a little bit of time. CO3, here I have one carbonate ion. CO3, here I also have one carbonate ion. Okay, so if I put the 2 in front of NH4, it makes the exact same changes, giving me 2 ammonium ions, 2 chlorides, and I'm now balanced. Okay, that's it, and that is a balanced chemical equation. Now let's practice one together, and we'll go over some hints and tips. Okay, we'll start off with a sentence. Notice that there are no chemical formulas and no symbols. It's got a capital letter at the beginning, oops, capital letter at the beginning and a period at the end. Yep, it's a sentence. So from this, let's write a word equation. Nickel 2 chloride burns, forming nickel 2 oxide and chlorine gas. But what's the other reactant? There isn't one listed. Aha, whenever you see the word burns, that means something is reacting with oxygen. So our other reactant is oxygen, and it's oxygen gas. Nickel 2 chloride plus oxygen gas react to form, we're going to put an arrow. Okay, we now have a word equation. We show the names of our compounds, nickel 2 chloride, symbols, plus, oxygen gas, the name of the other compound, which was not mentioned in our sentence, forms nickel 2 oxide and chlorine gas. Fantastic. We're ready for our next step, which is, that's right, a formula equation. Okay, we have a few things that we need to be careful about here, so let's proceed. Okay, nickel 2 chloride. Well, that's not hard, and we've got a formula for it. Now, we need to write a formula for oxygen gas. Well, oxygen is one of the elements that's diatomic when it's not in a compound, so oxygen gas would be O2. Now, we want to write a formula for nickel 2 oxide, and that would be NiO, and chlorine gas, which is also a diatomic molecule. So we have Cl2. Note that if you just write O or you just write Cl, it's not going to balance correctly, and your equation is wrong. A quick note here about states and symbols. The page number here refers to page 246 in Holt Modern Chemistry. But whenever we know the state that something is existing in, such as these, which are mentioned as being gas, we have to indicate that in our equation. And we do that by putting a small parentheses down below the element, an abbreviation of the state. The states that we recognize are solid, liquid, gas, and one other that you may not be familiar with. Aqueous solution. That means that the substance has been dissolved in water. Remember, whenever we're given the information, we need to include it. If we're not given the information, we shouldn't go around making guesses, though there are some rules that you'll learn as you go. Okay, so with that, we now have a word equation. Time to balance. I've recopied my formula equation. I've put a blank in front of each compound or element, and I've drawn a line straight down from my arrow to separate my reactants and my products. Now I'm ready to list each element that appears on each side. I've done that, and I'll now do a tally of how many of each element I have on each side. Okay, I've got 1 nickel, 2 chlorine, and 2 oxygen appearing on the reactant side, 1 nickel, 2 chlorine, and 1 oxygen appearing on the product side. Well, this doesn't look like it should be too hard. If I attempt to balance the oxygen is the only thing that's not balanced, so I'm going to attempt to balance that first. When I do that, I put a 2 here, which now gives me 2 nickel and 2 oxygen. So while my oxygen is now balanced, my nickel is unbalanced. Okay, how could I rebalance the nickel? Well, if I put a 2 in front of the nickel 2 chloride, I now have 2 nickels, but I now have 4 chlorine. Arrgh! This happens a lot. We'll go through some tips and tricks. Okay, so now the only thing left unbalanced is my chlorine. Well, chlorine is all by itself, which makes it easy because we can change the coefficient on chlorine without having anything else shift. And sure enough, if I put a coefficient 2 in front of my chlorine, I now have 4 chlorine atoms, and everything is balanced. Fantastic. Some things that you'll want to check after you write a balanced chemical equation. Can the coefficients be simplified? Anytime you see a bunch of 2's, you start to worry. But the fact that there's nothing in front of the oxygen means this cannot be simplified. So this is the final balanced chemical equation. Okay, let's run through tips and tricks, and then you can go practice on your own. Okay, so balance different types of atoms one at a time. Balance atoms of elements that are combined and that only appear once on each side first. That helps. If polyatomic ions appear on both sides as single units, balance them that way. And balance your hydrogen and oxygen last. Actually, that really applies to any element that appears all by itself. So whether you have something like calcium appearing by itself, or gaseous nitrogen appearing as a diatomic molecule, or bromine gas, chlorine gas, any of these that appear by themselves where you can balance those without affecting something else should be saved for last because they're an easy fix. Okay, let's do one more together, and I'll start you off with the formula equation. This is actually the formula equation for the combustion of the simple hydrocarbon ethylene. So this is ethylene gas. Yes, it's the same stuff that fruit gives off to ripen. Okay, so we're told that everything here is in a gaseous state, the ethylene, the oxygen gas, and it forms gaseous CO2 and some steam, some water vapor. All right, let's balance. Though this one looks deceptively simple because there are only 3 chemicals on every side of the equation, it's more complicated than it appears. Mostly because oxygen appears in 2 different places on the product side, both as part of the carbon dioxide and as part of the water. So that throws a monkey wrench into things. The saving grace is the fact that oxygen appears all by itself here. So once we get everything else balanced, we can kind of tinker with oxygen as long as we have an even number of oxygen atoms. Okay, let's get started. I'll start by attempting to balance the carbon, since it appears in only one compound on the product side. So to balance that, I'll put a 2 here, which gives me now 2 carbon atoms. It also changes the amount of oxygen I have, and I now have 4 oxygen, 5 oxygen. So how could I balance my hydrogen? Well, to get 6 hydrogen on the product side, I'd have to put a 3 here. That gives me 6 hydrogen, all right. But I now have, let's see, 3 plus 4, 7 oxygen. That's an odd number, and that's not going to work. So I know that I'm going to have to at least double my hydrogen. Why? Well, if I double this hydrogen, I get 4 carbon, 12 hydrogen, and I can get 12 hydrogen over here, and that gives me an even number of oxygens. So I now have 6 oxygens here and 4 oxygens there for a total of 10 oxygen. Is my carbon balanced? Nope. So if I put a 4 in front of my CO2, I now have 4 carbon, 8 oxygen there, 6 oxygen there. That gives me a total of 14 oxygen. Everything but oxygen is balanced. Is there a way to get 14 oxygen on the reactant side? Sure, because the oxygen is a diatomic molecule. I simply put a 7 there. That gives me 14, and everything is balanced. Okay, that's your introduction to writing chemical formulas and balancing them. We've discussed what they require, how to write them, and how to balance them. Now you're on your own to practice. Good luck.